Hello everyone and welcome back to the channel. Today we will be solving round 954 beautiful array. You are given an array of integers and an integer k. You need to make it beautiful. A beautiful array is a palindrome array. Okay, the operations you can perform are, first of all, you can shuffle the array elements as much as you like. And since you need a palindrome array and you can shuffle the array elements, that means that all you have to do is make doubles of values. If you have made doubles of values, that means you can anyways shuffle and make a palindrome. Okay, and you have an operation. You can increase the value of any number by k. Okay, so basically you need to make your array palindrome by adding the value of k to any number and shuffling the array elements as you like. You need to print the minimum number of operations needed to make the array beautiful or report that it is impossible. Now, let's suppose your k is 4. Then that means if you have a number, suppose 26, you increase it by 4, it becomes 30, again by 4, 34, again by 4, 38. If you check all of these numbers, mod 4 is equal to 2. That means that you can convert any two numbers equal if their mod k is equal. If you have two numbers like 24 and 26, 24 mod 4 is 0 whereas 26 mod 4 is 2. That means these two numbers will never be equal no matter how much you try. Okay, so first step is divide the numbers into groups modulus k. If you get a certain group like this here 26, 30, 34, 38, all of the values that lie within this range can be made equal or can be made into doubles. So after shuffling you can get a palindrome array. Okay, so first step what we did is divided the array elements into modulus k. Now suppose you have some k is equal to, let's say, 6. So you have at max 5 maps. Mod k is equal to 0, you have some subset of values. Mod k is equals to 1, you have some subset of values. All up to mod k is equals to 5, you have a subset of values. I have stored these values using a map of int and vector of int. So I can store this as int and this as a vector. Now, since you can perform operations only in one subset, that means if the value of n is even, that means each of these subsets need to be even size. If any of this subset is of odd size and you have an even n, that means you cannot find a suitable answer because you cannot perform operations from different subsets. And if your n is odd, at most one subset will have an odd length of subset. Hence, exactly one will have. If there are more than one having odd subset length, that means the answer is again -1. Okay, now you have found the case where your answer is existing. Now you need to find the number of operations. Now since you can perform operations only on that given subset, then let's perform operations on each subset one by one. Now let's say you have some subset of values. Let's keep our k is equals to 6 and let's keep this, I guess, mod 6 is equal to 2. So you have values like 8, 14, 26, 32. Now if your subset is even, the subset length is even, that means it is very easy to make this into doubles. Simply pick up pairs of two and make them equal. It will always give you the minimum number of operations. You can make 8 to 14 by one operation. You can make 26 to 32 by one operation. Even if you have some like this, you have 8, 14, 14 and 32. Still, making 8 to 32 will need 4 operations. If you are making 8 to 14, it gives one operation. 14 to 32, 3 operations. So at the end of the day, you will get the same number of operations. Okay, so we have found our suitable answer for even. If your current subset length is even, then all you have to do is iterate your given subset from left to right and make the value of the zeroth index equal to first index, second index to third index, and so on to the end. That will be your number of operations. Okay, now you have found the answer for even. Okay, this is how you would implement it. This map contains contains the modulus and this contains the subset. Okay, I have written the cases for -1 and then I first sort this array, now this vector. If my size is even, all I do is iterate it, find the difference of the adjacent elements divided by k, and that's my answer for even. Now for odd it gets a bit complex. Let's suppose you have a subset 8, 14, 20, 26 and 32. Now there are 5 elements, which means if you want to create a palindrome array out of these, you can choose any one value to be in the middle. Since the palindrome array with odd length will have one value in the middle having no other neighbor because it is equal to itself, and then the remaining values I will have to make it equal with each other. Now choosing which value to remove may be tough. This is how we did it. So let's say you have 8, 14, 20, 26 and 32. You need to find what will be the answer if I am keeping my ith index in my middle. That means I have to perform operations over here and here, and this will be my answer. So first of all, what I did is I brute force this for every I, and that led to a n square solution. Then I got TLE on test case 14, which made me know that this solution is correct, and then I just had to optimize it. This is how I optimized it. Now if I want to find the answer if I am keeping my ith index in my middle, okay, then I need to calculate the answer for this and this. Okay, now I'll show you with a bigger length. Okay, let's say you have some numbers 1 2 3 4 5 6 7 8. Okay, let's say you are removing this element, you are removing 5, you are removing 5. Okay, now if you are removing 5, the operations for ahead will be difference of this and difference of this. Same for behind, difference of this, difference of this. So this is how I created two vectors. I stored the difference of each value. Like for this, the difference between 9 and its next value is 0. Difference between 8 and its next value is 1. Difference between 7 and its next value is 1. Difference between 6 and its next value is 1. Now I will need to find the sum of alternate numbers. Now to make this easier, I directly store this as 2, means I added the value of I plus 2. So if I query what will be my answer if I am starting building from here, it will give me directly my answer. And if I query what will it make if I start from here, then I will directly get the answer 1. Okay. Now if there was something like 8, 9, 10, 11, then the value of 8 should have been 2 and 6 would have been 3. Now difference between 6 and 7 is 1 and the answer ahead is 2. So I add 1 to 2 and I get 3. I did a similar approach for the behind part. And so I just query the neighbor element and check what is the cost of making that entire segment equal, like into doubles. Okay, so then I need to just check two types of cases. First of all, if my ith value, I have even values, I have even number of values ahead and even number of values behind. Then what I did is I just have to query the ith plus 1 neighbor and ith minus 1 neighbor. Those will directly give me my answer. And if I had odd, if I had odd over here and odd over here, then it's something like 6, 7, 8 and 3, 4, 5, something like this. So I will query I plus 2 and I minus 2. So I will get this entire value, and then I just find the difference between this and this. Okay, so this this is our two cases. If I am removing my ith index, I find the number of ahead elements and behind elements. Okay, then I query the ith plus 1 value and the ith minus 1 value, and if it is odd, I plus 2 and I minus 2, and then two ultimate neighbors, and then add them, and then I calculate this for each I, and then the minimum of all of that I store in my answer and print it. Okay, so thank you guys for watching. Make sure to like, subscribe to the video to never miss another tutorial.